Welcome back tonight. We are going to sit beside the oldest campfire, not the one in your memory, not the one in your backyard or your favorite story, the one that flickered in the dark long before anyone could name it. Fire did not just keep our ancestors warm, it fed their brains, extended their days, gathered their groups, and quietly reshaped what it meant to be human. This is the story of how we learned to hold the flame. Before humans built cities, before language became stories, before the first myths were whispered into the dark, there was one trembling thing between us and the night fire. It did more than warm our hands. It changed what we ate, how we slept, how we gathered, and perhaps even how our brains could grow so large. Somewhere in deep prehistory, a dangerous natural force became a human companion, and nothing about our species was ever the same again. The night is older than human memory, older than language, older than the first stories that would ever be told beside a flame. It settles over the African landscape like a living thing, folding the trees into shadow, cooling the stones, swallowing distance until every sound seems closer than it should. In the dark, the world belongs to eyes that shine. Leopards move without hurry. Hyenas test the air with their noses. Insects rasp from the grass. Somewhere beyond the faint outline of thorn and branch, a large body shifts, breathes, waits for an animal without claws, without speed, without the crushing jaws of a predator. Night is not peaceful. Night is a border, and for a long time, our ancestors stand on the wrong side of it. Then, in some deep and uncertain moment, there is light. Not the soft light of dawn, not lightning flickering and vanishing across a storm front, not a wildfire racing too wildly to approach, but a smaller light held close to the ground. It moves against the dark in a way no sun ever does. It breathes. It consumes. It turns wood into glow, bone into charcoal, cold air into warmth. Around it, faces become visible. Hands appear and disappear in orange flashes. The grass beyond the light remains dangerous, but the center has changed. Something that once terrified animals now gathers them. Something that once came from the sky, from dry storms and burning forests, is now brought near, fed, guarded, and eventually expected. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, there may be no single night when fire makes us human. Evolution rarely gives history such clean scenes. It does not arrange itself like a myth, with one frightened ape reaching for one burning branch and waking up as something new. The evidence remains incomplete, and scholars still debate when controlled fire became a reliable part of human life. Some traces are ancient and difficult to read. Some burned sediments may come from natural flames. Some hearths are clear, but younger than the first bodies, that already look unmistakably human in important ways. The story is not a straight line from darkness to mastery. It is a long negotiation with heat, risk, hunger, fear, and opportunity. Still, fire sits at the center of one of the strangest transformations in the history of life. Many animals notice fire. Some flee it. Some birds in Australia have been observed taking advantage of flames to flush prey from grasslands, and certain species are drawn to burned ground after wildfires. But no other animal is known to have built its existence around fire the way humans do. No other creature has made flame part of its diet, its sleep, its tools, its migrations, its shelters, its myths, its cities, and eventually its machines. Fire begins as an outside force, older than our lineage, older than mammals, older than the forests that feed it. But at some point, humans do something more than survive it. They bring it into the circle. That circle is where the mystery begins. Imagine a group of early humans, or near humans, gathered close enough to feel warmth, but far enough to avoid sparks. Their bodies are not yet modern in every detail. Their language, if they have it, is not preserved. Their thoughts leave no fossils. What survives in the record suggests that they live in a world of hard choices. Food is seasonal. Meat is valuable, but dangerous to obtain. Roots and tubers may be tough, fibrous, and locked behind chewing and digestion. Raw flesh can carry parasites and decay quickly in heat. The day offers light, but also competition. The night offers concealment, but also predators. Every calorie matters. Every injury matters. A broken tooth, an infected wound, a bad hunt, or a cold, rainy night can become more than inconvenience. It can become a quiet sentence. Fire changes the terms of that sentence. At first, perhaps not dramatically, a burned landscape after a lightning strike might expose roasted seeds, softened underground storage organs, or dead animals already partly cooked by heat. The smell alone would have been impossible to ignore. Cooked food is not just warmer food. In many cases, it is easier to chew, easier to digest, safer to eat, and more efficient as fuel. Heat can soften plant fibers, break down starches, denature proteins, reduce some toxins, and kill many microbes. It can also make food more predictable, in a world where the stomach is not merely a stomach, but an engine competing with the brain for energy. This is where fire becomes more than a tool. A stone flake cuts, a digging stick press, a sharp bone pierces, but fire transforms. It takes one thing and makes it another. Tough becomes soft, cold becomes warm, darkness becomes a social space, damp wood becomes smoke. A carcass becomes a meal that can be shared more easily. A camp becomes a place that can be recognized after sunset. The change is physical, but it is also emotional. To sit near a flame is to create a small island of predictability in a world that does not promise safety. The creatures around that flame are still vulnerable. Fire does not make them invincible. It needs fuel. It can die. It can spread. It can burn skin, consume shelter, expose a camp, or vanish in rain. Keeping it alive requires attention. It invites a new kind of discipline. Someone must notice embers, gather wood, choose dry branches, carry coals, protect the hearth from wind, and understand which materials smoke, which flare, which smolder. Even before anyone understands combustion in scientific terms, fire teaches cause and effect with unforgiving clarity. Feed it, and it grows. Neglect it, and it fades. Mishandle it, and it punishes. This may be one of its deepest gifts. Fire rewards minds that can anticipate. It favors memory, patience, timing, and shared responsibility. It stretches awareness beyond the immediate moment. A group that depends on fire must think not only of the food in hand, but of the next hour, the next night, the next rainstorm, the next movement across open ground. It is easy to imagine, though difficult to prove, that fire encouraged a different rhythm of attention, not just reaction, but preparation, not just eating, but waiting, not just fleeing darkness, but holding a place within it. And the darkness matters. Humans are visually dependent creatures, but compared with many night predators, our natural night vision is unimpressive. We do not glide through blackness like cats. We do not map the world by smell like hyenas. We do not hear the faintest movement in grass, as well as the hunters that evolve to own the night. Fire bends that imbalance. It doesn't remove danger, but it changes the geometry of fear. Predators may hesitate at the edge of light. Insects may be discouraged by smoke. Cold air may lose some of its bite. Eyes around the hearth can remain open longer. Bodies can rest closer together. Hands can work after sunset. Social life can continue after the sun disappears. This is a quiet revolution, long before cities glow on the horizon, before metal is melted, before pottery hardens in kilns, before bread rises in ovens, before engines and electricity turn night into industry. There is the small prehistoric fire. Its light flickers across faces that cannot know what it will become. They do not know about neurons, calories, digestive trade-offs, or evolutionary selection. They do not know that future scientists will argue over burned bones, ash lenses, microscopic minerals, and the timing of brain expansion. They know hunger. They know cold. They know the relief of warmth against the skin. They know that the meat near the flame smells different. They know that the dark beyond the fire feels farther away than it did before. The first mystery, then, is not simply who struck the first spark. It is how a dangerous natural force became intimate. How something that once devoured forests became something tended by hands. How a flicker on the ground could begin to reshape bodies, habits, diets, sleeping patterns, and the hidden architecture of the brain. No single explanation fully accounts for this. Fire did not act alone. Climate, tools, meat-eating, cooperation, walking on two legs, changing landscapes, and countless accidents of survival all mattered. But fire gave the human story a new center of gravity. Around it, the ancient world did not become safe. It became negotiable, and in that negotiation, the long human night begins to change. Before fire becomes a companion, the ancient world is not empty darkness waiting for human invention. It is already alive with heat, drought, lightning, volcanic breath, and sudden burning grass. Flames move across landscapes long before any human hand learns to preserve an ember. They clear old growth. They open patches of green after rain. They leave behind charred trunks, exposed roots, roasted seeds, and the bodies of animals caught too slowly between smoke and wind. Early hominins live in a world where fire exists, but not yet as property, not yet as habit, not yet as a dependable center of camp. It is a visitor, a terror, a brief opportunity, and then it is gone. To imagine that world, it helps to remove the hearth from the human story. Remove the ring of warmth. Remove the glowing coals that make night feel smaller. Remove the steady smoke that marks a place as occupied. What remains is an animal life lived under pressure. Early members of the human line move through mosaics of woodland, grassland, river edge, scrub, and open ground, depending on the time and place. Some climb well enough to use trees, but they are no longer simply forest apes. Their bodies are changing toward upright walking, toward travel across broken landscapes, toward hands that can carry food and tools. But these changes come with costs. On the ground, height offers a view, but it also exposes the body. 2 legs free the hands, but they do not outrun a big cat. The predators are not background scenery. They're part of the evolutionary weather. Saber-toothed cats, leopards, hyenas, crocodiles, giant eagles in some landscapes, and other hunters shape the meaning of every path. A carcass may be food, but it may also be bait guarded by jaws. A water source may bring life, but it also concentrates danger. Tall grass can hide antelope, but it can hide the animal watching the antelope. Early humans and their relatives are neither helpless nor dominant. They are clever, social, increasingly skilled with stone, and often persistent. Yet without reliable fire, they do not command the dark. They endure it. Food is another kind of darkness, less dramatic, but just as powerful. Raw landscapes do not offer meals in the way modern people imagine meals. They offer problems. Roots must be dug from hard ground. Seeds must be gathered before other animals take them. Nuts must be cracked. Tubers may be tough, bitter, toxic, or protected by soil and stone. Meat, when available, brings calories and danger together. It spoils. It carries parasites. It demands cutting, tearing, pounding, chewing, and sharing before flies. Scavengers and heat erase its value. Bones hold marrow, but marrow must be opened. Hides cover flesh, but stone must do the work of teeth and claws. A raw diet is not impossible. Many animals thrive on raw food because their bodies are built for it. Large herbivores spend much of the day processing plants through enormous digestive systems. Carnivores have cutting teeth, acidic stomachs, and leaves organized around hunting and scavenging. Apes chew for hours, and their guts work through fibrous fruits, leaves, and stems with the patience of evolution. Early humans inherit part of that world, but they're moving away from it. Their teeth, jaws, hands, legs, and brains are changing in a strange combination. They're not becoming better apes in the ordinary sense. They're becoming something more dependent on behavior. That dependence is risky before fire is reliable. A sharp flake can open a carcass, but it cannot soften the meat. A pounding stone can break bone, but it cannot kill the hidden life inside spoiled flesh. A digging stick can reach underground storage organs, but it cannot transform them into a rich, soft food unless heat becomes part of the process. Scholars still debate how much meat, roots, fruit, seeds, and other foods different early human species depended on at different times. The evidence remains incomplete because meals rarely fossilize. What survives in teeth, bones, isotopes, stone tools, cut marks, and landscape patterns suggest flexibility, not a single perfect diet. But flexibility itself demands energy, memory, and cooperation. Without controlled fire, the day sets a hard boundary around that cooperation. Sunlight is working time. It is when eyes scan for plants, water, tracks, and danger. It is when hands break stone, carry infants, drag branches, strip flesh, dig, climb, gesture, and gather. As evening comes, the world contracts. A group must choose where to rest, and trees may offer safety for some bodies, but not every landscape provides convenient trees, and not every member of a group can climb easily. Infants, injured adults, older individuals, and those carrying food or tools complicate every escape. Ground sleeping without fire is possible, but it exposes the body to cold, insects, and predators. Tree sleeping offers height, but it limits space, comfort, and social gathering. Every solution is partial. This matters because sleep is not simply the absence of action. It is a biological necessity that leaves an animal vulnerable. To sleep deeply, the body must trust the place. To sleep long enough, the group must reduce danger. Humans today sleep in ways that are unusual among primates, with relatively shorter, deeper sleep and long periods of social life surrounding darkness. But before reliable fire, ancient hominins likely live under a different pressure. Night may be broken, alert, uneasy. Some individuals may watch, while others rest. The edge of sleep may remain close to the edge of fear. No single explanation fully accounts for how human sleep changed, but fire would later become one of the great candidates for making ground sleep safer, warmer, and more socially organized. Cold adds another pressure. Africa is often imagined as uniformly hot, but ancient African environments are varied, and nights can turn sharply cold in open country, highland zones, dry seasons, and exposed shelters. Beyond Africa, the problem becomes even greater. Before humans can move widely into colder latitudes and harsher climates, they need more than strong legs and sharp stones. They need ways to buffer the body against temperature. Clothing, shelters, fat, group behavior, and landscape knowledge all matter. Fire eventually becomes part of that survival system. But before it is dependable, cold is a boundary drawn directly on skin. And then there is the mind. Without fire, early hominins still think, learn, remember, and solve problems. They are not waiting passively for a spark to awaken them. Stone tools appear long before clear evidence for habitual hearths. Social life is already deep. Mothers carry infants for years. Young individuals learn where to find food, how to handle objects, when to approach, and when to retreat. Groups likely recognize each other, compete, cooperate, and remember places across seasons. The human story does not begin with fire, but fire changes the scale on which these abilities can operate. Before that change, intelligence remains tied more tightly to daylight, raw food, immediate danger, and the daily exhaustion of survival. Occasionally, natural fire must have offered glimpses of another possibility. After a grass fire, an early human group might enter a blackened plain while smoke still hangs low, and the soil remains warm beneath ash. They might find insects exposed, seeds cracked by heat, small animals killed, or roots easier to pull from loosened ground. The smell of roasted flesh would not require language to be meaningful. A burned patch might briefly become a strange feast, dangerous but valuable. Yet taking advantage of fire is not the same as controlling it. A creature can follow fire without owning it. It can eat what fire leaves behind without knowing how to make fire return. That difference is enormous. To control fire means to cross from opportunity into responsibility. It means not merely approaching the burned ground after the flames have passed, but carrying the living heat forward. It means recognizing embers as future flame. It means finding fuel before cold arrives. It means building habits around something that is never truly tame. Before humans owned fire, the world may have offered clues everywhere. Lightning split trees, volcanic glow, smoke columns on the horizon, the sweet smell of roasted plants after a burn. But clues are not mastery. For hundreds of thousands of years, perhaps longer, perhaps with starts and losses, as different places, the human line lived beside this possibility without fully turning it into a way of life. The dark, then, was not just darkness. It was the shape of a limit. Raw food was not just food uncooked. It was the shape of an energy problem. Cold was not just discomfort. It was the edge of range. Predators were not just danger. They were the owners of hours humans had not yet claimed. Before the hearth, our ancestors lived with all the ingredients of transformation scattered around them. Hands, tools, hunger, memory, social bonds, and a world that burned on its own. What they did not yet have was the small, guarded center that could hold those ingredients together. Somewhere ahead, in deep time, sparks would stop being accidents alone. But before that could happen, early humans had to learn the oldest lesson. Fire teaches the difference between what the world gives for a moment and what a group can keep alive. The first sparks in the human story do not arrive as clean evidence. They arrive as stains in the ancient sediment, riened patches of earth, blackened fragments of bone, cracked stones, altered minerals, and arguments that can last for decades. Fire is dramatic when it burns, but it is strangely fragile after time has passed. A flame leaves no skeleton, Smoke does not fossilize into a simple confession. Heat changes things, but heat can come from many sources, and an archaeologist working hundreds of thousands or more than 1,000,000 years later must ask a difficult question. Was this the work of humans? Or was this only the landscape burning on its own? That uncertainty is where the trail begins. In the deep past, wildfires are common enough that burned material alone cannot prove controlled fire. Lightning can ignite dry grass. Volcanic activity can burn vegetation. Natural brush fires can sweep across floodplains, caves, and open woodland. A bone may be charred because someone placed it in a hearth, but it may also have lain on the ground when a fire passed over it. Stones may crack from heat in a human camp, but they may also fracture in a natural blaze. Even ash can move. Water, wind, animals, collapsing cave floors, and later human activity can disturb old deposits until the original scene is blurred almost beyond recognition. So, the search for early fire is not a search for one blackened object. It is a search for pattern. Archaeologists look for burned material concentrated in a way that seems deliberate. They look for repeated burning in the same place, for signs that heat was contained, for sediments altered at temperatures that match hearth conditions, for burned bones mixed with stone tools, for microscopic ash particles, for plant remains transformed by fire, for heated stone lying in positions that suggest human use rather than random natural burning. The evidence must be read like a damaged manuscript, with most of its pages missing. What survives in the record suggests moments of contact with fire very early in human evolution. But whether those moments show full control remains one of the great problems. Some of the oldest proposed traces come from Africa, where early members of the human line live among shifting grasslands, woodlands, lake margins, and river systems. At sites associated with very ancient hominins, researchers have found burned bones or heated quartz sediments that may date back well over 1,000,000 years. Places such as Wonderwork Cave in South Africa have become especially important because the evidence appears inside a cave, away from the ordinary path of open grass fires. There, microscopic analysis has suggested the presence of burned plant ash and bone fragments deep in ancient deposits. If the interpretation is correct, it may show that early humans were using fire inside the cave roughly 1,000,000 years ago. But even here, the wording remains careful. Using fire does not automatically mean making fire. Bringing burning material into a cave, preserving embers from a natural source, or taking advantage of fire repeatedly would all be important steps, but they are not identical. That distinction matters more than it first seems. A group may know how to maintain fire without knowing how to ignite it from nothing. They may carry embers wrapped in bark, dry grass, dung, or fungus-like materials. They may depend on lightning fires when they occur, then guard the flame for as long as possible. They may lose it and wait days, weeks, or longer before finding another source. Such a world would be very different from the later human world where fire can be produced deliberately, with friction, percussion, or other techniques. Early fire use may have passed through long stages of attraction, scavenging from burned landscapes, cautious approach, transport of embers, maintenance at camp, repeated use, and only much later, reliable fire-making. Scholars still debate how long these stages lasted, and whether different human groups moved through them at different times. In East Africa, the evidence is equally intriguing and equally difficult. Archaeological sites in places such as Kubora and Chisawanja have produced claims of ancient burning, including reened clay and altered sediments. Some interpretations suggest that early humans may have encountered or used fire more than 1,000,000 years ago. Yet, the problem remains the same. Ancient fire can be natural, and natural fire can leave traces that imitate human behavior when the context is incomplete. A patch of reined earth might come from a hearth, but it might also result from burning tree roots, brush fire, or other heat events. The older the site, the more time has had to rearrange the evidence. In deep prehistory, certainty becomes expensive. Outside Africa, the story becomes even more complicated. Some sites associated with Homo erectus or other early humans have been proposed as evidence for fire use in Eurasia. Chokudian in China, famous for fossils often associated with peeing man, was once treated as a landmark for early fire control. Burned bones and ash-like deposits seem to tell an obvious story. Ancient humans gathered in caves and used fire. Later research complicated that picture. Some of the supposed ash deposits were reinterpreted, and the original context was damaged by earlier excavation methods, wartime losses, and the difficulty of old archaeological records. The site remains significant, but it is also a warning. What appears obvious in one scientific generation may become uncertain in the next when methods improve. This is not a failure of archaeology. It is how deep history is refined. Fire is not proven by romance. It is proven or challenged by sediment chemistry, mineral magnetism, microscopic structure, experimental burning, spatial analysis, and comparison with natural fire signatures. A hearth that looks convincing to the eye may not survive laboratory scrutiny. A faint stain that looks unimpressive in the field may reveal under magnification that it contains ash, heated bone, and minerals transformed in ways that suggest controlled burning. Modern science has made the search for ancient fire both more powerful and less simple. It gives researchers better tools, but it also removes easy answers. By around several 100,000 years ago, the evidence for regular fire use becomes stronger in many parts of the Old World. The hearths appear more clearly. Burned bones and stones occur in repeated association with human occupation. Sites show patterns that are harder to explain as accidents of wildfire. In some places, fire seems integrated into camp life, food processing, warmth, and possibly tool-making. Yet even here, the timing varies. Fire does not spread through the human world like a single invention announced everywhere at once. It appears unevenly, perhaps because environments differ, traditions differ, fuel availability differs, and some groups may lose techniques that others preserve. That unevenness is important because evolution is often imagined as a ladder, but the archaeological record looks more like scattered lights in a vast darkness. One group may use fire often, another may use it rarely. A population may know how to maintain flame, but not create it reliably. A wet landscape may make fire harder to preserve. A dry, open habitat may make natural fire easier to find. A cave may protect evidence, while an open-air campsite may leave almost nothing after erosion, trampling, and rain. The absence of evidence does not always mean the absence of fire, but neither can every burned trace be turned into proof. No single explanation fully accounts for the pattern. The first uncertain sparks, therefore, reveal two stories at once. One is about ancient humans learning to live with a force that could warm, cook, protect, and destroy. The other is about modern humans trying to reconstruct that learning from fragments almost too small to bear the weight of the question. A dark smear in cave sediment becomes a possible turning point in evolution. A burned bone becomes a clue to diet, danger, and night. A retweened patch of clay becomes part of a debate about whether a creature with a growing brain was already changing the rules of survival, and perhaps that is fitting. Fire itself is never still. It flickers, shifts, escapes, dies, returns. The evidence it leaves behind behaves the same way across time. It refuses to become a simple origin story. It asks for caution. It asks for imagination, held tightly beside doubt. Somewhere behind those blackened fragments are real hands, real hunger, real nights, and real flames. But the distance is immense, and the first firekeepers remain half hidden in smoke. Long before modern humans appear, another kind of human walks across the ancient ground with a body built for distance. Homo erectus is not a creature of one valley or one forest edge. It is a traveler, a survivor of open spaces, a maker of stone tools, and perhaps one of the first great firekeepers in the human story. Its bones appear across a vast span of time and geography, from Africa into parts of Eurasia, carrying with them the image of a being more human-like in posture and movement than any earlier crossaster. The legs are long. The body is more committed to walking and running across land. The hands are free. The face is still ancient, the brow heavy, the brain smaller than ours but larger than those before it. And somewhere around this form of humanity, the question of fire begins to burn more steadily. Homo erectus lives in a world that demands range. Climate shifts open and close habitats. Grasslands expand, woodlands retreat, lakes rise and shrink, rivers change course, animal herds move, and the resources that once held a group in one place may vanish with a season. To survive in such a world, movement becomes knowledge. A group must remember water, stone, shelter, animal paths, fruiting times, dry wood, safe crossings, and dangerous ground. Fire, if it is being carried or maintained, becomes part of that moving memory. It is not merely something found after lightning. It becomes something that can travel with the group. Fragile, but powerful, a living ember hidden inside ash or bark, protected from wind like a small animal that must be fed. The evidence remains incomplete, and scholars still debate how consistently Homo erectus controlled fire. It would be too simple to imagine every group of Homo erectus sitting around tidy hearths every evening. The archaeological record does not allow that certainty. Some sites suggest early burning, others preserve no clear trace. Some ancient landscapes were likely too exposed, too wet, or too disturbed for fire evidence to survive. Yet, the possibility that Homo erectus became increasingly familiar with fire fits many pieces of the larger puzzle. This species, or a close relative within the same broad human world, appears at a time when bodies are changing in ways that invite questions about diet, energy, and behavior. The teeth of Homo erectus are smaller than those of many earlier hominins. The jaws are not as massive. The gut does not fossilize, but the body proportions suggest a shift away from the heavy, digestive machinery needed for constant processing of tough, raw plant matter. The brain is expanding. The body is becoming more efficient over distance. These changes do not prove cooking by themselves, but they make cooking a powerful suspect. A creature that spends fewer hours chewing, extracts more energy from food, and shares softened meals around a fire would live differently from one bound entirely to raw plants and occasional raw meat. No single explanation fully accounts for the anatomy, but fire belongs near the center of the debate. Imagine Homo erectus at the edge of a dry season plain. The air smells of dust, dung, and distant smoke. Herd animals move in loose lines toward water. Scavengers circle above a carcass. Stone flakes lie near a butchery place where hands have cut through hide and tendon with practiced force. Without fire, meat must be eaten raw or dried by sun and air, and the group must compete with decay. With fire, even irregularly used, the meaning of that carcass changes. Flesh can be warmed, softened, made safer. Bones can be cracked after roasting. Tough plant foods gathered nearby can become easier to chew. The meal can last longer into evening, and the group can remain together in a way that daylight alone does not allow. The firekeeper's task may not be dramatic. It may be patient, repetitive, and easy to overlook from a modern distance. Someone gathers dry grass. Someone breaks dead branches. Someone pushes embers beneath ash to keep them alive. Someone notices that certain woods burn hot and fast, while others hold coals through the night. Someone learns that wet fuel smokes, that wind can save or destroy a flame, that dung can smolder, that a small coal can be carried if protected. These are not small discoveries. They are the beginnings of a technical relationship with the world. Fire is chemistry without language, physics without equations, and the lesson is written in heat. There is lesser-known difficulty in imagining early fire. Use control may have begun long before invention. Modern people often think of fire mastery as the ability to make sparks on demand, but maintaining fire may be older than making it. A group that cannot create flame from nothing may still become expert at keeping it alive once obtained. Such a group would treat fire as precious, not casual. Losing it might mean losing cooked food, warmth, protection, and long evening light until another natural fire appears. The hearth would not merely be convenient, it would be a responsibility carried by the group, perhaps shaping daily movement as strongly as water and food. Homo erectus also lives in relation to stone. The famous Aurelian hand axe tradition associated with Homo erectus and later humans across immense stretches of time shows a mind capable of planning form before completion. A hand axe is not just a broken rock. It is shaped through repeated blows into a tool with symmetry, edges, and intention. Fire and stone together create a different kind of creature from one that only reacts to immediate hunger. Stone cuts the world open. Fire transforms what is cut. Stone tools allow access to meat, marrow hides, wood, and plant materials. Fire changes their texture, safety, and meaning. Together, they make survival increasingly technological. Yet Homo erectus is not modern humanity in disguise. Its inner life remains mostly beyond reach. The evidence does not show complex art, elaborate burial, or symbolic worlds in the way later periods sometimes do. What survives suggests endurance, adaptation, and technical competence across enormous time that may be more impressive than a sudden miracle for hundreds of thousands of years. Perhaps more than 1 million forms of Homo erectus and related humans persist through changing climates and unfamiliar lands. Fire, whether occasional at first or increasingly habitual, may have helped stretch the limits of where such humans could live and what they could eat. The night around a Homo erectus camp would still be dangerous. Predators would still watch. Children would still be vulnerable. Rain would still threaten the flame. Hunger would still return. But a group with fire has altered the terms of the landscape. The camp becomes easier to defend. The evening becomes longer. Food becomes more flexible. The body receives energy in a new form. Social life has a brighter center. The ground itself may preserve the faint circular memory of heat, ash, and trampled earth, waiting for a future species to uncover it and argue about what it means. What makes Homo erectus so haunting is not that it gives us a finished answer, but that it stands near the threshold. Behind it are earlier hominins living close to natural fire, but not clearly transformed by it. Ahead are humans for whom fire becomes ordinary, portable, expected, and eventually cultural. Homo erectus occupies the long middle ground where the flame may have moved from rare chance toward repeated practice. In that middle ground, the human body stretches across continents. The brain grows more demanding, the mouth changes, the hand becomes more skilled, and the night begins to lose some of its ancient authority. The first firekeepers may not have understood that they were changing evolution. They may have understood only the immediate truth. Embers must be protected, wood must be gathered, food near heat becomes different, and darkness is easier to face when the center holds. But in deep time, those small acts gather weight. A branch placed on coals, a carcass turned toward heat, a child sleeping near warmth, a group lingering after sunset. These are not the grand inventions usually carved into history. They are quieter than that. They are the habits from which humanity slowly becomes possible. The body keeps records that stone tools cannot. Teeth remember what they had to crush. Jaws remember how much force they had to carry. Ribs and pelvises hint at the size of the organs once packed inside. Even when soft tissue vanishes, evolution leaves traces in architecture. And one of the most important changes in the human story may be written not in flame itself, but in the gradual reshaping of the mouth, gut, and face. Cooking does not simply make food pleasant. It changes what food demands from the body. It turns eating from a battle of raw resistance into something more efficient. And in deep time, efficiency can become destiny. A raw meal is work. Raw meat can be tough and elastic, especially when eaten without the knives, grinders, and controlled preparation modern people take for granted. Raw tubers and roots can be fibrous, gritty, bitter, or chemically defended. Seeds may be hard. Nuts may be locked behind shells. Leaves and stems require long chewing and fermentation. Even fruit, the gentler food of many primates, is seasonal and not always abundant in the landscapes where early humans travel. For an ape-like ancestor, the day is not divided neatly between activity and mealtime. Eating itself is activity. Chewing takes hours. Digestion takes space. The gut becomes a large internal workshop, extracting life from resistant matter. Heat changes that equation. When food is cooked, starches can gelatinize, proteins unfold, connective tissues soften, and many plant materials become easier for teeth and enzymes to handle. The exact effect depends on the food and the method, and scholars still debate how early humans cooked before pottery, ovens, and controlled containers, roasting in embers, placing food near hot stones, charring roots in ash, warming meat over open flame, or baking underground in simple pits, may all belong to later or earlier moments in different forms. The evidence remains incomplete, but the principle is powerful. Fire performs part of the body's labor outside the body. This may sound simple, almost domestic, because modern kitchens hide the violence of the transformation. But for an early human body, cooked food could mean less time chewing, less energy spent breaking food down, and more usable calories from the same landscape. That matters because evolution does not reward what is elegant. It rewards what can be paid for. A large jaw, enormous chewing muscles, broad molars, and a heavy gut are expensive systems. They serve a purpose, but they require tissue, growth, blood flow, and daily maintenance. If behavior begins to do some of their work, natural selection can slowly favor bodies built differently. Across human evolution, the face changes. The massive chewing structures of earlier forms become reduced in later humans. Teeth become smaller, jaws become less projecting. The body plan of Homo erectus and later humans suggests a creature less committed to non-stop, raw processing than many earlier ancestors. This does not prove that cooking caused every change. No single explanation fully accounts for the pattern. Meat eating, stone tools, pounding, cutting, climate shifts, changes in plant use, and social food sharing all matter. But cooking offers something unusually broad. It affects plants and animals. It affects safety and energy. It affects chewing and digestion. It reaches into the daily rhythm of life. One of the most striking ideas associated with the cooking hypothesis is that humans may be biologically adapted to cooked food in a way no other animal is. Modern humans can survive on raw diets if carefully managed, but doing so can be difficult, especially when energy demands are high. Studies of raw food diets in recent humans suggest that even with modern blenders, knives, global supply chains, and abundant cultivated foods, some people struggle to maintain enough energy over time. That does not map perfectly onto ancient life, and it should not be treated as a simple experiment in prehistory. Still, it hints at something important. The modern human body does not behave like the body of a chimpanzee, gorilla, or baboon, simply waiting for raw food to arrive. The gut is central here, though it rarely survives in the fossil record. Compared with great apes, humans have a relatively smaller colon and a digestive system shaped around energy-dense, higher-quality foods. That shift did not happen because one ancestor suddenly discovered roasted meat and transformed overnight. It would have unfolded slowly, with many overlapping pressures. Stone tools could make raw meat easier to eat by slicing it. Pounding could soften plant foods. Cooperative foraging could widen the menu. But cooking goes further. It can unlock calories that would otherwise remain partly inaccessible. It can reduce the toughness that makes chewing costly. It can make certain foods safer by killing many pathogens and parasites. It can reduce some toxins, though not all, and sometimes cooking creates new risks of its own. Fire is not a perfect purifier. It is a powerful filter. The mouth tells part of this story. Powerful jaws are useful when food resists. Large teeth are useful when chewing dominates survival. But a smaller face can become possible when behavior changes the food before it enters the mouth. This may have had consequences beyond diet. A reduced face changes the shape of the head. It changes space, balance, muscle attachment, and eventually the relationship between skull, brain, and airway. It would be too neat to say cooking made the human face alone. Evolution is rarely so obedient, yet the possibility remains compelling. The hearth may have helped reshape the head, not by touching bone directly, but by changing the daily force applied to bone across generations. Cooking also changes time. A group that eats raw, tough food may spend long periods chewing and processing. A group that cooks may spend more time waiting for food to heat, but less time chewing afterward. Waiting itself becomes social. Food near fire cannot always be eaten instantly. It must be watched, turned, shared, protected from animals, removed before it burns, allowed to cool. Around that process, a new rhythm develops. The meal becomes less like a scramble and more like an event. This does not require modern table manners or language in any familiar form. It only requires that heat creates delay, and delay creates opportunity for attention to gather. There is also a strange intimacy in cooked food. Raw food can be taken and consumed quickly. Cooked food often passes through a shared space before it reaches the mouth. It smells widely. It signals value before it is eaten. It may attract others, including competitors and predators. This makes cooking socially dangerous as well as socially useful. A group must manage access: who gets the best piece, who feeds children, who watches the fire, who returns with fuel, who waits, who steals, who shares. Such questions do not need spoken rules at first, but they create pressure for social understanding. Food softened by fire may have fed not only strong adults, but also infants being weaned, older individuals with worn teeth, and injured members who might otherwise struggle. What survives in the record suggests that human groups increasingly depend on care, learning, and cooperation. Cooking could have deepened that dependence. The surprising detail is that fire may have made humans less individually self-sufficient, while making groups more powerful. A solitary animal can eat raw food as it finds it. A fire, using human, depends on fuel, timing, knowledge, and companions who do not simply take everything. Cooking may increase calories, but it also creates a visible resource worth defending. It can make camps more stable, but also more attractive. It can free energy from food, but only if the group maintains the behavior that makes that energy available. In this way, the cooked body and the social body evolve together. The stomach, jaw, hand, and group are not separate stories. By the time cooked food becomes habitual, if it does, the ancient human body is living inside a transformation larger than hunger. Food enters the mouth, already changed by culture. Even before full culture in the later symbolic sense has arrived, heat becomes an invisible ingredient in anatomy. Flame works through meat, tubers, bones, seeds, and marrow, and then through the bodies that depend on them. The result is not a sudden leap into modern humanity, but a slow loosening of old constraints. Less chewing, more energy, smaller teeth, a different gut, a new rhythm of eating, with a group drawn again and again toward the same warm center. And somewhere in that warm center, another organ waits to become more expensive than any other. The brain is the most demanding fire in the human body. It does not glow, it does not smoke, yet even at rest, it consumes an astonishing share of the energy a human body works to gather, chew, digest, and protect. In an adult modern human, the brain is only a small part of body weight, but it uses roughly a fifth of resting energy. In infants and young children, the demand is even more extreme. A growing brain is not a luxury organ. It is expensive tissue, and evolution does not keep expensive tissue unless something can keep paying the bill. This is the expensive brain problem. Larger brains can bring advantages: memory, planning, social awareness, tool use, flexible learning, and a wider ability to survive changing conditions. But they are costly before they become useful. Brain tissue needs constant fuel. A bigger brain can also lengthen childhood because complex neural systems take time to grow and organize. Children with long development need food, protection, teaching, and patience. A species cannot simply become more intelligent by desire or accident alone. It must find enough energy to build intelligence and enough social stability to raise the slow, growing young who carry it. Across the human line, brain size increases unevenly. Australopithecines have brains not much larger than those of living apes. Later members of Homo show expansion, though never in one clean-up woodward march. Homo erectus has a larger brain than earlier hominins, and later humans continue the pattern in fits and starts. Scholars still debate the forces behind each stage: meat-eating, stone tools, social complexity, climate instability, movement, cooperation, and competition all belong in the explanation. But fire, and especially cooking, offers a powerful way to understand how a growing brain could be fed. Raw food sets limits. A large primate can spend much of its waking life chewing and digesting, and that strategy works if the animal's body and environment support it. But a creature walking across open ground, making tools, carrying infants, watching predators, and traveling between water sources cannot spend endless hours with its jaws locked in labor. There are only so many daylight hours. There are only so many safe feeding windows. There is only so much gut tissue a body can maintain while also supporting longer legs, active movement, and a larger brain. Cooking changes the arithmetic by softening food and making more calories available. Heat can increase the energy gained from the same amount of material. It can turn hard starch into a more accessible fuel. It can make meat easier to chew and digest. It can reduce the energetic cost of processing food inside the body. The exact numbers are difficult to reconstruct for ancient diets, and the evidence remains incomplete. But the direction is clear enough to matter. Food altered by heat can deliver energy differently than food eaten raw. Repeated generation after generation, that difference becomes more than a convenience. It becomes an evolutionary possibility. There is a famous idea sometimes called the expensive tissue hypothesis, which suggests that the energy required by a large brain may be balanced by reductions in other costly tissues, especially the gut. Humans have relatively large brains and relatively smaller digestive systems compared with what might be expected for a primate of our size. This does not mean the gut simply shrank because the brain demanded tribute. Evolution is not a budget meeting, but bodies do face trade-offs. A digestive tract built for huge amounts of fibrous raw plant matter is expensive. If diet quality improves through meat, tool processing, and cooking, then the body may be able to support a smaller gut and a larger brain. No single explanation fully accounts for this, but cooking makes the trade-off easier to imagine. Fire also changes the reliability of energy. A raw landscape gives food unevenly. Some seasons are generous, others are thin. Some foods are edible only after heavy processing. Some are dangerous and less treated. Cooking widens the usable menu. Tubers, roots, seeds, marrow, meat, and tough plant materials can become more valuable when exposed to heat. This matters not only for adults, but for children. A young human with a growing brain is a creature of extraordinary need. Soft-cooked foods may have helped weaning, allowing infants to receive energy-rich meals before they could handle all the raw foods adults might exploit. This possibility is difficult to prove directly because the meals of ancient children are among the most fragile things in the archaeological record. The social side of the brain cannot be separated from the nutritional side. A larger brain is useful in a group where relationships matter. Who shares food? Who remembers favors? Who knows where water lies after a dry season? Who can read anger before it becomes violence? Who can learn tulm by watching? The human brain does not evolve simply to solve abstract puzzles. It evolves in bodies, surrounded by other bodies. Fire intensifies that world. It gathers individuals into a visible center. It delays eating. It makes food more shareable and more stealable. It creates tasks that require coordination, fuel gathering, tending coals, guarding children, watching meat, maintaining camp. Around the hearth, the mind has more to track. Night adds another layer. Without fire, darkness limits social time. With fire, evening becomes available. The hours after sunset can hold grooming, tool repair, food distribution, teaching, quiet observation, and perhaps the early forms of storytelling long before stories become preserved in myth. It is impossible to know exactly what early humans thought or said around ancient flames. The record preserves no voices, but the change in setting is profound. A protected, illuminated, warm space after dark allows social life to extend beyond the urgent, daylight economy of finding food and avoiding danger. There is a tempting but misleading way to tell this story. Fire made food better. Better food made brains bigger. Bigger brains made humans. The real story is less tidy and more interesting. Brains likely helped humans use fire, while fire helped feed brains. Social cooperation helped protect hearths, while hearths deepened cooperation. Tools made food easier to access, while cooking made accessed food more rewarding. Climate instability favored flexible minds, while flexible minds found new ways to survive instability. Cause and effect form a circle, not a straight road. A lesser-known complication is that bigger brains do not automatically make a species safer. They make infancy riskier. They make childbirth more demanding. They make childhood longer. A large brain child is not born ready to survive. It must be carried, fed, guarded, and taught. Cooking may have helped not only by supplying calories, but by making food easier for many ages and conditions to consume. A worn-toothed elder, a pregnant mother, an injured hunter, and a weaning child can all benefit from softened food. What survives in the record suggests that the human brain did not expand because one invention solved one problem. It expanded in a changing web of behavior, anatomy, ecology, and chance. But fire stands out because it touches so many parts of that web at once. It reaches the stomach through cooking, the hand through tending, the eye through nightlight, the group through sharing, the child through softer food, the journey through warmth, and the imagination through transformation. The ancient flame outside the body and the hidden flame inside the skull become linked. One burns wood, bone, grass, dung, and branches. The other burns the hard-won calories of a difficult world. Between them lies the human bargain. Feed the fire, feed the brain, protect the group, raise the young, remember the place, return before dark. The brain does not become human in a single leap beside the hearth, but beside the hearth, the cost of becoming human may have become payable. When the sun drops below the ancient horizon, the human story changes its temperature. Daylight has always belonged partly to the eyes, to movement, to searching, cutting, digging, carrying, following tracks, watching clouds and animals, and the subtle signs of water. But night is different. Night removes distance. It turns a familiar path into a question. It gives power to sound, smell, and imagination. Long before humans learned to fill the darkness with lamps, torches, oil, cities, screens, and electric glare, the first dependable fires begin to carve small territories out of the black. This is one of fire's quietest revolutions, and perhaps one of its deepest. Cooking may help feed the body and brain, but firelight changes time. It takes hours that once belonged mainly to caution and makes them available for social life. The group no longer has to disappear into separate resting places as soon as darkness rises. It can gather, it can see faces, it can watch hands, it can remain awake without being fully exposed to the night. A hearth does not abolish fear, but it gathers fear into a ring, gives it edges, pushes it outward beyond the light. For an animal like an early human, this matters intensely. Human eyes are powerful in daylight, excellent at color, detail, gesture, and distance, but they are not the eyes of nocturnal predators. A leopard can move through dimness with a confidence humans do not possess. Hyenas can interpret the night through smell and sound with a patience older than our lineage. Many prey animals survive darkness by alertness, numbers, and nervous sleep. Humans bring something else to the problem. They bring a flame that makes the dark visible in fragments, and those fragments are enough to change behavior. Around a fire, the landscape becomes layered. Closest to the coals are hands, feet, tools, food, children, sleeping bodies, and the careful glow of embers. Just beyond that is the shifting zone, where light touches grass, stones, cave walls, tree trunks, or the low frames of temporary shelters. Beyond that is the true dark, moving and listening. The edge of firelight becomes a borderland. Eyes may flash. There a branch may crack. The group may pause, but the center holds. The ancient night, once absolute, now has a human interior. Scholars still debate how early controlled fire became a nightly habit, and the evidence remains incomplete. A hearth preserved in sediment can show that fire burned in a place, but it cannot easily show how people felt beside it, how long they stayed awake, or how much their social lives expanded after sunset. Yet the inference is powerful, because fire does something no stone tool can do. It extends visibility into darkness. It allows activity after the natural workday ends. Even if early fire use was irregular at first, every reliable evening flame would have created a new pocket of time. Time is not a small thing in evolution. A few extra hours of safe wakefulness can become hours for learning. A young individual can watch an older hand strike stone, strip bark, shape wood, crack bone, or prepare food. Movements difficult to see in full daylight chaos may become clearer in the focused glow of the hearth. Firelight is unstable, but it is intimate. It pulls attention inward. It makes gestures stand out against shadow. It turns a group's shared space into a kind of natural classroom long before any formal teaching exists. The night hearth may also have changed memory. During the day, attention is scattered across survival, hunger, heat, thirst, danger, distance, insects, children, and weather all compete for the mind. At night, near a protected fire, the world narrows. The body is tired, but the group is together. Events of the day can be repeated through gesture, expression, rhythm, and eventually words. A dangerous animal encountered near the river, a fruiting tree found beyond a ridge, a dead branch that burned well, a path that failed, a place to avoid. No one can prove when such exchanges became story, but the conditions for story become stronger when a group has light, warmth, and time after dark. This is where fire may have touched language without leaving a direct trace. Language does not fossilize, and the earlier speech is beyond recovery. Bones can hint at anatomy, genes can suggest capacities, tools can suggest planning, but the first long evenings of communication vanish almost completely. Still, a hearth creates a social setting where vocal exchange becomes valuable. Around a fire, individuals are close enough to hear one another. Faces are visible enough for expression. Hands are free. Food may be shared. Children are present. The group is not moving. In such a space, communication can thicken. What begins as calls, gestures, emotional sounds, and practical signals may across immense time become more structured ways of holding a shared world in the mind. No single explanation fully accounts for the rise of human language, and it would be too simple to say fire created speech. But fire may have lengthened the stage on which speech could evolve. It gave the day an afterlife. It allowed social intelligence to operate when foraging had paused. It made the group visible to itself. There is another subtle change. Firelight alters emotion. Darkness naturally magnifies uncertainty. A sound in the grass can be anything until it is seen. A cold wind can make the body curl inward. The absence of light can isolate individuals even when they are near one another. Fire reverses some of that isolation. It makes warmth shared. It makes faces return. It allows eye contact after sunset. It gives tired bodies a reason to stay close. The hearth is not merely a defensive technology. It is a mood-making technology, an ancient machine for gathering nervous systems into the same glow. Modern people still feel this, though often without noticing its age. Campfires quiet conversation differently from electric rooms. Flames invite staring. They create pauses without emptiness. They turn ordinary silence into something companionable. This response may not be a perfect window into prehistory, but it suggests that fire engages attention in a distinctive way. It moves constantly, but not randomly. It is dangerous, but contained. It is alive in appearance, though not alive in fact. For a mind built to detect motion and meaning, flame is almost hypnotic. Around it, alertness can soften without disappearing. For early humans, that balance between alertness and rest may have been crucial. A group beside fire can relax more deeply than a group exposed in darkness, but it must still remain aware. Someone tends the embers. Someone wakes to add fuel. Someone hears movement outside the ring. Sleep may become more organized. Individuals may take turns resting and watching. Infants sleep in warmth. Older bodies avoid the worst cold. Smoke keeps some insects away, though it also irritates eyes and lungs. Fire solves problems while creating new ones, as all powerful tools do. Predators may not have feared fire in the simple, absolute way people sometimes imagine. Animals vary. Some avoid flames. Some approach camps. Some learn quickly when food is available. A hungry predator is not a symbol. It is a calculating body. Yet fire changes the risk. It produces light, smoke, sound, human presence, thrown embers, burning branches, and group confidence. Even if it only reduces danger rather than removing it, that reduction can matter over thousands of nights. Evolution often works through small differences repeated until they are no longer small. Night becomes human territory, not because humans conquer it, but because they learn to hold a portion of it. The first hearths are islands, not empires. Beyond them, the dark remains vast. Rain can drown the coals. Wind can scatter sparks. Fuel can run out. A careless moment can burn skin or shelter. But inside the ring, a new kind of life becomes possible. Longer evenings, shared food, protected sleep, closer learning, deeper memory, and the slow shaping of minds that do not simply survive the day, but carry the day forward into darkness. The flame that cooks the meal also illuminates the faces that share it. It turns bodies toward one another. It makes the group a visible thing after sunset. And in that glow, the human world begins to stretch beyond the sun. A hearth is never just a fire. It is a decision made visible on the ground. To place flame in one spot and return to it, to feed it, sleep near it, cook beside it, and let bodies arrange themselves around its heat, is to begin shaping space in a new way. Before walls, before villages, before built rooms and doorways, the fire becomes a kind of center. It tells a group where warmth gathers, where food changes, where children should remain close, where tools may be repaired, where smoke rises, where danger is watched, and where the day will end. This change can be subtle in the archaeological record. A few centimeters of ash, burned bone, reened sediment, charcoal fragments, stones darkened by heat, and concentrations of tools may be all that remain of a place once filled with bodies, smells, voices, insects, smoke, fatigue, and hunger. The evidence remains incomplete because camps are fragile things. Wind scatters ash, rain washes away charcoal, animals disturb bones, later occupations trample older traces. Open-air sites are especially vulnerable, while caves and rock shelters preserve some clues more faithfully, but not always clearly. Still, when hearths appear repeatedly in human spaces, they reveal something profound. Fire is no longer only an event. It has become architecture without walls. The earlier shelters of the human line are difficult to reconstruct. Some groups may have used trees, natural caves, rock overhangs, brush wind bras, and simple arrangements of branches, hides, grass, or other plant materials. Most of those materials vanish quickly. Stone tools and bones survive far more often than woven fiber, bark, leaves, or wood. What survives in the record suggests that humans and their relatives used landscapes intelligently, choosing places that offered water, visibility, raw materials, shade, and protection. Fire adds another layer to that choice. A good camp is no longer only a place to rest. It is a place where fuel can be found, smoke can escape, sparks can be managed, and warmth can be held through the night. Smoke is one of fire's less romantic gifts. Modern people often imagine prehistoric fire as pure golden light. But anyone who has sat near damp wood knows that fire is also coughing, stinging eyes, shifting wind, blackened fingers, and the smell of burned resin clinging to hair and skin. Smoke can irritate lungs and fill a poorly ventilated shelter until comfort becomes impossible. It can reveal a camp from far away. It can make food taste bitter. Yet, smoke can also protect. It discourages some insects. It helps preserve meat and fish when used in certain ways. It marks the human presence in the landscape. It may even have helped early humans tolerate places where biting insects made rest difficult. Though scholars still debate how important this was in different environments, insects deserve more attention than they usually receive in grand stories of human evolution. Mosquitoes, flies, ticks, lice, fleas, and biting midgets are not dramatic predators, but they can shape sleep, health, and movement. They irritate wounds, carry disease, swarm around carcasses, and make certain wetlands or warm seasons miserable. A smoky fire does not create perfect protection, and no single explanation fully accounts for human success in insect-heavy environments. But smoke changes the immediate air around a camp. It can give bodies a little more rest. It can keep flies from food for a little longer. It can make the edge of a river, a cave mouth, or a damp shelter more tolerable. In deep time, small comforts repeated nightly are not trivial. They become part of survival. Warmth is more obvious. The body spends energy maintaining its own temperature, and cold steals that energy with silent efficiency. In open landscapes, high elevations, dry seasons, glacial periods, and windy nights, warmth can mean the difference between rest and exhaustion. Fire allows humans to carry a pocket of heat into places where naked skin would otherwise fail, quickly. This does not mean fire alone allowed migration into cold regions. Clothing, body fat, shelters, planning, social care, and knowledge of animals and seasons all mattered. But fire made cold negotiable. It could dry wet hides, warm hands stiff from work, protect infants, comfort older individuals, and turn a cave entrance or windbreak into a livable place. The relationship between fire and shelter is especially important because fire changes the inside of a place. A cave without fire is darkness, stone, cold, damp, echo, and animal smell. A cave with fire becomes partly human. Its walls reflect light. Its ceiling collects soot. Its floor gathers ash, bones, flakes, footprints, and sleeping places. The same is true of a rock shelter or a brush camp. Fire does not need permanent architecture to create interior space. The boundaries made by heat and light. A group can feel the difference immediately, inside the glow, outside the glow, near the smoke, beyond the smoke, close enough to be warmed, far enough not to burn. But the hearth also disciplines movement. Fuel does not gather itself. A group that uses fire regularly must understand the landscape in a new way. Dry wood becomes a resource. So does dung in some environments. Reinous branch, bark, grass, and anything that can catch or hold heat. Children may learn which sticks smoke, which snap, which are too green, which burn down to lasting coals. Adults may plan camp locations partly around fuel availability. A shelter far from wood may be cold, no matter how safe it looks. A place with fuel, but no water, may be useful only briefly. Fire ties camp life to environmental knowledge as tightly as hunger does. Predator defense remains complicated. Fire is often imagined as a magical wall that wild animals refuse to cross. But the real ancient world is less tidy. Some predators avoid human fires. Others may circle at a distance. Scavengers may be attracted by smells. Bold animals may test the edge of camp if hunger is strong enough. Still, fire gives humans options they otherwise lack. It lets them see eye shine. It creates smoke and sparks. It allows branches to become weapons of heat and light. It concentrates people in a defensible circle. It may make a group appear larger, louder, and more dangerous than its bodies alone suggest. Even a partial reduction in nighttime predation could have altered the cost of sleeping on the ground. Ground sleep is one of the great hidden transformations in the human story. Many primates sleep in trees or nests above the ground, safer from some threats, but constrained by branches, balance, and space. Humans eventually become committed ground sleepers, and fire may have helped make that possible. The evidence cannot show the first comfortable night, but the logic is strong. A warm, smoky, guarded hearth makes ground rest less dangerous. It allows bodies to lie closer together. It may permit deeper sleep, more stable infant care, and better recovery after long travel. Scholars still debate how sleep, fire, social guarding, and shelter interacted, but the hearth belongs in any serious account of how humans came to rest as they do. Daily rhythm changes around this center. Morning may begin with embers under ash, not with a cold start. Someone stirs the coals. Someone adds dry grass. Smoke lifts into the dawn. Food left from the previous night may be warmed. Tools are collected from around the hearth. Children learn to avoid the hottest stones. The group moves out into the landscape, but the camp remains marked by ash and memory. At evening, bodies return with fuel, meat, roots, seeds, or empty hands. The fire becomes the place where the day is sorted into use. What can be eaten now? What can be saved? What must be guarded? What broke? Who is injured? Who needs warmth? Who has gone too far into silence? A hearth, therefore, creates not only comfort, but continuity. It allows one day to connect to the next. Embers from last night become flame this morning. Bones from one meal become tools, waste or fuel for later heat. Ash marks where people sat. Charcoal preserves the memory of wood chosen by hands. Around the fire, camp becomes a repeated pattern rather than a temporary scatter of bodies. That repetition matters because culture begins in repeated patterns long before it becomes art, myth, or ceremony. The ancient fire is smoky, imperfect, dangerous, and demanding. It burns fingers. It fills shelters with haze. It requires work when bodies are tired. It can fail at the worst possible moment. Yet it gives back more than heat. It gives structure to space, rhythm to days, protection against some dangers, and a center around which fragile human lives can gather. In the long story of becoming human, survival is not only about the brain growing larger or the diet becoming richer. It is also about finding a place in the dark where the body can rest. The child can sleep, the old can remain warm, and the group can wake to embers instead of emptiness. Fire does not only gather wood, it gathers people. Once a flame becomes a repeated center of camp life, the group begins to organize itself around something more powerful than shelter alone, and more complicated than hunger alone. A hearth creates a place where food is transformed in public, where warmth is shared unequally but visibly, where children remain close, where tired adults return from different tasks, and where the rewards of the day pass through a common circle before they disappear into individual bodies. In that circle, the human animal becomes more social, not simply because it enjoys company, but because survival begins to depend on a new kind of cooperation. Food sharing is older than cooking, and cooperation is older than humans. Many animals cooperate. Many primates share food under certain conditions, groom one another, form alliances, protect infants, reconcile after conflict, and remember social debts. Early humans do not invent social life from nothing beside the fire, but fire may have intensified the social stakes of eating. Raw food can often be consumed at the moment it is found. A fruit can be eaten in a tree. A strip of raw meat can be torn away quickly. A root can be chewed apart by whoever holds it. Cooked food often requires delay and attention. It sits in the shared space, smelling valuable before it is ready. It must be watched. It must be protected from burning, from animals, and from other hands. It turns appetite into a social problem. That problem may have shaped human behavior in ways still visible today. Around a fire, food becomes easier to divide, but also harder to hide. The smell of roasting meat travels. Softened tubers can be distributed to children, injured adults, pregnant mothers, strong hunters, elders, and those who returned with little. A carcass, processed with stone tools and fire, can feed more mouths than one individual can manage alone. But sharing is never automatic. It must be negotiated, enforced, expected, or emotionally rewarded. A group that cooks together must somehow manage patience, trust, resentment, generosity, and theft. No single explanation fully accounts for the rise of human cooperation, but the hearth creates a powerful stage on which cooperation can become daily practice. There is a quiet but important difference between gathering around food and gathering around cooked food. Cooking creates waiting time. Waiting time creates observation. Individuals see who contributes fuel, who brings meat, who gathers roots, who tends children, who eats first, who holds back, who takes too much, who shares when watched. and who shares even when not forced. Social reputation may deepen in such conditions. The group can remember patterns. This one is reliable. This one steals. This one feeds a child that is not their own. This one knows how to keep embers alive in damp weather. What survives in the record cannot show these judgments directly, but human societies everywhere are built from remembered behavior. Fire would have made behavior easier to see. The emotional architecture of the group may also have changed. Warmth pulls bodies closer, and closeness changes relationships. Around a flame, individuals sit within sight of one another for longer periods than daylight. Foraging often allows. Grooming, resting, nursing, repairing tools, touching, watching, and quiet vocal exchange can happen in the same shared glow. This kind of closeness does not eliminate conflict. In fact, it may create new conflicts because valuable food and limited warmth attract competition. But repeated closeness also allows bonds to thicken. The hearth becomes a place where tolerance is practiced. Not perfect harmony, but managed proximity. Children would have experienced fire differently from adults. For them, the hearth may have been danger, fascination, lesson, and comfort at once. A child must learn not to reach into flame, not to step on hot ash, not to scatter embers, not to waste fuel, not to approach food before it is safe. These lessons require watching older individuals and being corrected by the group. Fire teaches through pain. If teaching fails, it turns knowledge into a matter of survival. Very early in life, a young human raised near fire grows up not only with a body fed by cooked food, but with a mind trained to respect invisible consequences. Heat remains after flame fades. Smoke follows wind. Dry grass catches faster than greenwood. A small coal can become a dangerous blaze. This may have encouraged teaching in a subtle way. Many skills can be learned by trial and error, but trial and error around fire is costly. A child who mishandles a stone may bruise a finger. A child who mishandles fire can burn a shelter or destroy the group's stored embers. The need to prevent dangerous mistakes may have favored closer attention from adults, more demonstration, more warning gestures, and eventually, more precise communication. Scholars still debate how teaching, imitation, language, and social learning evolve together. But fire belongs among the forces that made accurate learning valuable. It is hard to be casual with a tool that eats mistakes. There is also the matter of fairness. Fire may have helped create a more public economy of food. In a purely individual scramble, the strong can often take quickly and vanish. Around a hearth, the group witnesses distribution. That visibility may have strengthened expectations. The hunter who brings meat may receive status, but the gatherer who brings tubers may feed the group just as surely. The elder who no longer travels far may still tend coals, watch children, prepare materials, or remember where fuel remains after rain. A pregnant mother may need soft, energy-rich food. A weaning child may depend on what adults process. The hearth makes survival less about one heroic individual and more about a network of contributions. This is one reason fire may have changed the meaning of weakness. In many animal lives, injury or age quickly becomes isolation. A creature that cannot feed itself efficiently falls behind. In fire, using human groups, softened food and shared warmth could help some vulnerable individuals survive longer. That survival is not guaranteed, and prehistoric life remains harsh. But even small increases in care matter. An elder with worn teeth may still eat cooked food. An injured adult may recover near warmth. A child too young for tough raw foods may receive mashed or softened meals. In return, vulnerable individuals can still carry knowledge, relationships, and emotional value. The group becomes a container for lives that solitary survival might discard. The hearth may also have encouraged division of labor without making it rigid. Some individuals may become better at finding fuel, others at butchery, digging, tool repair, fire tending, watching infants, or reading weather. These are not modern jobs, but recurring tendencies. Fire links them because it turns many separate tasks into one shared outcome. In the evening meal, the safe camp, the living embers. A branch gathered hours earlier becomes warmth after dark. A stone flake struck in daylight cuts meat that later cooks. A root dug from the soil becomes soft enough for a child. The group's scattered efforts return to the center. A lesser-known consequence of cooking is that it may make food theft both more tempting and more punishable. Cooked food is immediately valuable because someone else has already paid the cost of gathering, processing, and heating it. To steal cooked food is to steal concentrated labor. This could create stronger pressure for social rules, punishment, alliances, and reputation. Disputed or unsupported versions of this idea sometimes turn the hearth into a simple origin of morality, which goes too far. Human moral life has many roots, but the cooked meal is an ancient arena where fairness, patience, entitlement, care, and anger would have been hard to avoid. The fire circle is therefore not a peaceful postcard from prehistory. It is a social furnace. It warms, but it also tests. It reveals hunger, generosity, fear, fatigue, hierarchy, affection, and dependence. It forces bodies together at the very moment valuable resources are being transformed. It gives the group longer hours to bond, but also longer hours to disagree. It makes children safer, but also teaches them danger. It feeds the brain, but also demands a brain capable of managing the social heat around the flames. And perhaps that is why the hearth feels so deeply human. It is never only a technology. It is a relationship between bodies, food, risk, memory, and trust. Long before written law, before temples, before villages, before kings and markets and kitchens with doors, there are a ring of light on ancient ground where individuals learn night after night. That survival depends not merely on finding food, but on returning with it, changing it, sharing it, defending it, and sitting close enough to one another that the warmth can be felt by more than one body. Beside the hearth, hands begin to see differently. A stone lying in daylight is already useful if it breaks the right way, but near fire, it becomes part of a larger world of transformation. Wood hardens in heat. Resin softens and becomes adhesive. Ochre changes color. Bone dries, cracks, and can be shaped. Hide warms and loosens. Meat pulls away from sinew. Even stone itself can behave differently after careful heating. Fire teaches that materials are not fixed. They have moods, limits, hidden possibilities, and breaking points. To a mind already learning the language of stone flakes and cutting edges, this lesson is immense. The older stone tools long predate clear evidence for habitual fire. Early humans and their relatives are already breaking rocks with intention before the hearth becomes a reliable center of life. They know that certain stones fracture into sharp edges, while others crumble uselessly. They know where good raw material can be found, how it feels in the hand, how a blow travels through a core, how a flake can open hide, strip flesh, sharpen wood, or scrape a surface clean. Toolam is already a conversation with matter. Fire adds a new voice to that conversation. At first, the link may be accidental, A wooden branch left near coals becomes harder at the point. A digging stick scorched in ash resists wear a little better. A bone tossed into fire becomes brittle. A lump of mineral pigment darkens or reens. A stone heated too quickly explodes or cracks apart, teaching danger with sharp fragments. The hearth is a laboratory before anyone knows what a laboratory is. Its experiments are not written down. They are remembered in bodies, habits, scars, and repeated success. What survives in the record suggests that later humans learned to use fire with remarkable technical subtlety, but the earliest stages remain mostly hidden. Wood is one of the great missing materials of prehistory. Stone survives. Bone sometimes survives. Charcoal survives under the right conditions, but most wooden tools vanish. Though wood must have been everywhere in ancient technology, spears, digging sticks, clubs, carrying poles, frames for shelters, handles, wedges, and simple containers made from bark or hollowed material may have been common, long before they become archaeologically visible. Fire can shape wood in ways stone cannot. A shaft can be straightened with heat. A tip can be charred and scraped to a harder point. Resin can be melted to help attach stone to wood. The record preserves only rare windows into this world, but those windows hint at a much richer technology than stone tools alone suggest. The wooden spears from Schöningen in Germany, much later than the earliest fire debates, but still deep in the Ice Age world, show how sophisticated prehistoric woodworking could become. They are balanced, carefully shaped hunting weapons, not crude branches. They remind us that ancient humans were working imperishable materials with skill that often disappears from the ground. Fire may have played a role in such woodworking, whether in hardening, straightening, heating adhesives, or maintaining working spaces. The evidence remains incomplete for many periods and places, but it is difficult to imagine advanced wood technology developing entirely apart from heat. Adhesives reveal an even more surprising side of ancient intelligence. To attach a stone point to a wooden shaft or handle is to make a composite tool, a tool built from different materials that must work together. This requires more than a sharp edge. It requires planning the relationship between stone, wood, fiber, resin, pitch, sinew, or other binding materials. Some later prehistoric humans used birch tar, plant resins, ochre mixtures, and other adhesives that may require controlled heating. Birch tar in particular has fascinated researchers because producing it can involve heating bark in low oxygen conditions, a process that suggests careful control of temperature and environment. Scholars still debate how complex the earliest tar-making methods were and whether some could occur through simpler procedures than once assumed. Even so, the point remains, powerful fire could help humans make materials that did not exist in the usable form before heat touched them. Ochre adds another layer. Iron-rich pigments appear in many prehistoric sites, sometimes ground, scraped, heated, or transported. Ochre can be practical, symbolic, or both. It can color hides, bodies, tools, adhesives, or surfaces. Heating can change its hue, turning yellowish minerals redder through chemical transformation. The meaning of ochre varies by context, and no single explanation fully accounts for its use across the deep past. Some of it may be technical, some decorative, some social, some symbolic, and some unknown. But near fire, pigment becomes another material that changes under human attention. Color itself becomes something that can be altered. Stone also enters the fire's influence. Heat treatment of stone is a later and more clearly documented technology in some regions where carefully heating certain rocks makes them easier to flake or improves their fracture qualities. This is not casual burning. Too much heat can ruin the stone. Too little may do nothing. Successful heat treatment requires knowledge of material, temperature, timing, and often slow cooling. It shows a mind thinking ahead, preparing a stone now so it will break better later. That idea belongs to a more advanced technical world than the earliest hearths, but its roots lie in the same ancient lesson. Fire teaches again and again the properties of matter can be changed before use. The hearth also changes the working day. In firelight, tools can be repaired after sunset. A broken edge can be retouched. A hide can be scraped. A spear can be examined. Fibers can be twisted. Bones can be cracked for marrow and then discarded into ash, where future archaeologists may find them burned, splintered, and mixed with flakes. The light is not perfect. It flickers and throws shadows, but it is enough to extend handwork beyond daylight, especially for tasks already familiar to touch. Evening tool repair would not leave an obvious label in the ground, yet it may have mattered greatly. A group that wakes with sharp tools begins the next day differently from one that must prepare everything at dawn. Fire may also have helped humans manage risk in tool-making. A good stone source might be far away. A broken spear point at the wrong moment could cost food or safety. A hafted tool takes time to build. A sharpened stick must be kept dry and ready. The hearth becomes a maintenance zone, a place where the group restores its equipment and prepares for what has not yet happened. This is another way fire encourages anticipation. It draws the mind forward. Not only what is needed now, but what will be needed when the herd moves, when the cold comes, when the camp shifts, when the hunt begins. There is something almost philosophical in this technical life, though the people living it would not have separated thought from action. Fire shows that the world has layers. A branch is not only a branch. It can become a spear, a coal, a torch, a support, a digging tool, or ash. A stone is not only a stone. It can become a blade, a scraper, a heated core, a hammer, a weight, a hearthstone. Resin is not only sticky tree blood. It can become glue. Bone is not only waste. It can become fuel, tool, needle, point, or memory. The human mind becomes powerful partly because it stops accepting materials as they first appear. This does not mean fire alone creates technology. Hands, eyes, social learning, memory, and ecological pressure are all essential. Nor does every ancient human group use fire in the same way. Traditions differ. Environments differ. Some materials are abundant in one region and absent in another. Some techniques may be invented, lost, reinvented, and altered across thousands of generations. But once fire enters the technical world, the range of possibility expands. Tools are no longer only shaped by force. They are shaped by heat beside the hearth. Then evolution is not only biological, it becomes material. The growing brain is fed by cooked food, but it is also trained by resistant matter stone that breaks, wood that bends, resin that melts, pigment that reends, bone that chars, flame that rewards patience and punishes haste. Each successful transformation leaves no grand announcement, only a slightly better edge, a straighter shaft, a warmer camp, a stronger bond between parts that nature did not assemble on its own. The fire that makes food edible also makes imagination practical. It shows early humans that the world can be edited. As humans move farther through the ancient world, fire begins to travel with them, not as a simple possession, but as a portable climate. It does not erase cold, hunger, distance, or danger, yet it allows bodies born in warmer evolutionary settings to enter landscapes that would otherwise punish exposed skin and limited night vision with ruthless efficiency. The human line begins in Africa, but the story does not remain there. Across deep time, different human population spread into the Middle East, Europe, Central Asia, East Asia, island edges, highlands, forests, coasts, and steppe worlds where seasons could turn survival into a severe test. In these places, flame becomes more than comfort. It becomes one of the ways humans negotiate the planet itself. The first movements out of Africa are not one simple migration. They are pulses, experiments, expansions, retreats, replacements, and crossing shaped by climate, geography, population, and chance. Homo erectus and related early humans reach parts of Eurasia long before modern humans exist. Later, Neanderthals, Denisovans, Homo sapiens, and other populations occupy different regions, sometimes separately, sometimes overlapping, sometimes leaving genetic traces in one another. Fire belongs to this wider expansion, though not always in the same form or with the same intensity. Scholars still debate how regularly early Homo erectus used fire in every region. But by the time later humans face Ice Age environments, controlled fire is deeply woven into survival. To understand what that means, imagine a cold plain near the edge of a glacial world. The air is dry enough to cut the throat. Frost stiffens grass. Herd animals move in slow, dark lines across open ground, their breath briefly visible before wind tears it away. A human group stands near a shelter of hide, brush, bone, stone, or a rock overhang, depending on place and period. Their clothing is not modern, but it may include hides, furs, sinew bindings, and scraped skins shaped by patient labor. Tools lie near a hearth where ash has been pushed aside and embers are coaxed back into flame. Without fire, the landscape is not merely uncomfortable, it is a machine for draining heat from the body. Cold changes everything. It changes the energy needed to survive. It changes which plants grow and when. It changes the movement of animals, the availability of water, the hardness of ground, the length of winter darkness, and the meaning of shelter. Fire allows humans to warm themselves, dry materials, cook calorie-rich food, process hides, melt snow or ice when necessary in later cold regions, and gather at night when outside conditions press close. It is not the only answer to cold, but it is an answer that can be renewed again and again if fuel is available. A group with flame has a center that the climate cannot entirely own. Fuel becomes a geography of its own. In wooded landscapes, dead branches, trunks, bark, resin, and brush may be gathered, though wet weather complicates everything. In open steppe or tundra-like environments, wood can be scarce, and people may turn to shrubs, grasses, bones, dung, or driftwood near rivers and coasts. Burned bone at some prehistoric sites may reflect not only cooking or waste disposal, but fuel use in places where wood is limited. This is one of the less romantic details of Ice Age fire. The hearth may smell not only of cedar, pine, or dry grass, but of fat, marrow, dung, damp hide, and old bones slowly giving up heat. Survival rarely has the clean scent later imagination gives it. Fire also transforms movement. A group crossing unfamiliar terrain must think about the next camp before the current one is abandoned. Where is dry fuel? Where is water? Where will smoke be trapped? Where can children sleep out of the wind? Where can predators be seen approaching? Fire makes place selection more strategic. It turns migration into a chain of possible hearths. A valley without fuel may be crossed quickly. A cave with smoke-blackened ceilings may become a repeated refuge. A riverbank with driftwood may hold a group longer than an open ridge. The map inside the human mind grows warmer and more detailed. In colder worlds, food often requires more processing. Meat from large animals can be rich, but it must be butchered, divided, cooked, dried, smoked, or guarded from freezing, scavengers, and decay, depending on season. Fat becomes precious because it carries dense energy. Marrow, brains, organs, and stored body fat of animals matter greatly. Fire helps render, soften, warm, and preserve in simple ways. Though the exact techniques vary and are difficult to reconstruct, plant foods may be seasonal and limited in some Ice Age environments, but where roots, seeds, nuts, or other resources exist, heat can make them more useful. The cold does not remove the cooking hypothesis. It makes the energy problem sharper. The relationship between fire and migration is especially important for Homo sapiens. As modern humans spread widely across the planet, by the time our species enters high latitude, Eurasia, and later moves toward regions such as Siberia and beyond, fire is not an optional experiment. It is part of a survival package that includes clothing, shelter, tools, social learning, hunting strategies, symbolic communication, and long-distance planning. Yet even then, the evidence remains incomplete. Many camps vanish. Organic materials rot. Hearths are disturbed. The farther back researchers look, the more they must reconstruct from fragments, charcoal flecks, burned bone, stone arrangements, reened earth, soot on ceilings, and the distribution of artifacts around heat. Neanderthals offer a particularly revealing comparison. They live for hundreds of thousands of years across western Eurasia, enduring glacial and interglacial cycles, cold steppe, forests, mountains, and caves. They use fire regularly in many contexts, cook food, make tools, process materials, and occupy shelters where hearths appear repeatedly. Their world is not a crude prelude to modern humanity. It is a deeply adapted human world of its own. Fire and Neanderthal life reminds us that flame did not belong only to Homo sapiens. The hearth is older and wider than our species, shared by relatives whose bodies, skills, and minds were human in their own ways. Denisvan, known mostly from DNA and fragmentary fossils, likely lived across parts of Asia, including harsh and varied environments. Their genetic legacy in some present-day populations includes adaptations linked to high altitude, especially through ancestry connected to Tibetan populations. The direct evidence of Denisovan fire use is limited because so little of their material world has been securely identified. But any human population enduring cold caves, mountain zones, or seasonal extremes would have faced the same basic pressures of warmth, food processing, and shelter. Here caution matters. It would be unsupported to fill Denisvan life with detailed fire scenes as if archaeology had preserved them clearly, but it's reasonable to see them within the broader human pattern. Ancient humans moving through demanding worlds where heat could become survival. Fire also lets humans carry daytime skills into hostile seasons. Hides can be scraped near warmth. Wet clothing or coverings can be dried. Adhesives can be prepared. Stone tools can be repaired in long winter evenings. Children can learn without leaving the shelter's edge. Stories, roots, animal behavior, and seasonal knowledge can be repeated while snow or rain erases tracks outside. In cold regions, the hearth becomes not just a nightly center, but a seasonal archive. It is where the group stores memory, when the landscape becomes difficult to read. Still, fire brings limits. It cannot create fuel when none exists. It cannot protect a starving group from failed hunts. It cannot prevent smoke inhalation in cramped shelters. It cannot remove the dangers of burns, wild spread, or carbon monoxide in poorly ventilated spaces. It does not make Ice Age humans invulnerable. Many groups must have failed. Some fires went out and were not recovered. Some shelters filled with smoke. Some cold nights took the weak, despite every ember. The human expansion across harsh landscapes is not a triumphal march. It is a long series of narrow survivals, and yet the pattern holds. Wherever humans go, fire eventually appears as one of their signatures. Not always preserved, not always understood, not always easy to date, but present again and again as warmth. Ash, charcoal, cooked bone, soot, and altered earth. The same force that once flickered in African darkness now burns under rock shelters in Europe, in caves of Asia, near rivers, plains, mountains, and frozen edges of habitable land. It becomes a companion to migration, a small sun carried into places where the real sun is weak, low, or absent for too many hours. The fire does not make humans masters of the Ice Age. It makes them negotiators. It lets them bargain with cold, darkness, raw food, wet hide, frozen ground, and distance. Around it, the traveling group carries not only heat but continuity, the memory of previous camps, the knowledge of fuel, the skill of keeping embers alive, and the trust that somewhere ahead, when the light fails, another circle can be made. Ash is one of the quietest witnesses in prehistory. It does not have the drama of a skull, the clean edge of a stone blade, or the immediate emotional force of a footprint pressed into ancient mud. It is soft, easily scattered, easily mistaken, and easily lost. Yet ash can carry the memory of one of the most important behaviors in the human past. In a thin, pale lens on a cave floor, in blackened sediment under a rock shelter, in microscopic mineral crystals invisible to the naked eye, the ancient hearth leaves clues that can change the story of evolution. To read those clues, archaeologists must become investigators of disappearance. A fire burns brightly for a few hours, perhaps through the night, perhaps for many nights in the same place. People gather around it, cook food, drop bones, push aside embers, add branches, scrape tools, warm hands, and leave. Then time begins its slow destruction. Rainwater seeps through sediment. Wind disturbs the surface. Animals dig. Later, humans step on the same ground. Roots grow through ash. Cave ceilings flake and fall. Minerals dissolve, move, recrystallize. What began as a clear hearth becomes blurred into the earth itself. By the time scientists arrive, the question is no longer simply whether something burned. The question is whether the burning was human. The first visible clues can seem simple. Charcoal is dark. Bone turns black, blue, gray, white, or chalky, depending on heat and oxygen. Sediment can reen when iron minerals are altered by high temperature. Stones can crack, craze, or change color. A hearth may appear as a basin of ash and charcoal surrounded by burned material, but deep time rarely leaves scenes so generous. At many sites, the evidence survives only in fragments. A few burned bones mixed with unburned ones, a patch of heat, altered earth, tiny pieces of charcoal, or an unusual concentration of artifacts around a stain. The evidence remains incomplete, and every trace must be judged against natural explanations. Microscopes have changed the search. What looks like ordinary dirt can contain ash crystals, burned plant tissues, heated clay particles, and microscopic bone fragments altered by temperature. Under magnification, a cave floor becomes a layered history of activity. Thin sections of sediment can be cut and examined like stone pages. Researchers look for the structure of the ash, the arrangement of particles, the direction of trampling, the signs of repeated occupation, and the difference between material burned in place and material washed in from somewhere else. A hearth is no longer only a visible circle, it can be a pattern of minerals. Chemistry adds another layer. Heated sediments may preserve changes in magnetic properties because fire can alter iron-bearing minerals. Certain compounds can indicate burned organic matter. Bone exposed to heat changes in crystallinity. Charcoal can sometimes be identified by plant type, offering hints about fuel choice, local environment, or what materials were available. Burned stone tools may reveal exposure to temperatures high enough to suggest deliberate heating. Each method gives a different kind of testimony, and none is perfect alone. The stronger cases come when several lines of the evidence point in the same direction. Burned material in a human occupation layer associated with tools, food remains, repeated hearth features, and microscopic signatures of controlled burning. Burned bones are especially revealing, but also treacherous. A bone can burn in a cooking fire, a waste fire, a wildfire, or a later natural event that sweeps across an old site. Color alone is not enough. Blackened bone may come from partial burning. White calcined bone may indicate higher temperatures. Cracking patterns can suggest whether bone was fresh or dry when burned. Cut marks on burned bone can imply butchery before burning, while burning before breakage may suggest different handling, yet even with all this caution remains necessary. Ancient bone is a poor witness when taken alone. It must be placed back into the scene around it. The position of a hearth also matters. A fire inside a deep cave is harder to explain as a passing grass fire than burning on an open plain. That is one reason places like Wonder Cave are so important in debates about early fire. When burned plant ash and bone fragments appear in ancient cave sediments far from the entrance, researchers must consider human transport or use more seriously. But even cave evidence requires care. Material can move through water, burrowing, roofall, or later disturbance. In archaeology, context is the difference between a clue and a coincidence. Open-air sites are even more difficult. A camp beside a lake, river, or plain may have been used repeatedly, but erosion can erase hearths or scatter remains. A wildfire may burn across the same surface where humans once made tools. Floods can carry ash from elsewhere. Sun, wind, and trampling can destroy charcoal. As a result, the absence of fire evidence at an open-air site does not always mean ancient humans lacked fire. It may mean the record failed to preserve it. This is one of the hidden frustrations in the story. Fire may have been more common than the surviving evidence suggests, or less common than hopeful interpretations imagine. Scholars still debate the balance. Hearths, when clearly preserved, can reveal more than fire itself. Their placement inside a shelter can show how people use space. At some sites, hearths cluster in repeated locations, suggesting preferred activity areas. Tools may concentrate near them. Food remains may gather around them. Sleeping or working zones may be inferred from artifact patterns. In later prehistoric contexts, multiple hearths can show group size, repeated visits, seasonal use, or social organization. The fire becomes a map. Not a perfect map, but a trace of how bodies arrange themselves in relation to heat, light, smoke, and work. Ash can also reveal fuel choices. Wood charcoal may preserve the anatomy of trees and shrubs, helping reconstruct ancient vegetation. Bone fuel can suggest environments where wood was scarce, or situations where people used every available resource. Dung fuel, when identifiable, can indicate the presence of grazing animals and human. Willingness to burn materials, modern imagination may overlook. Fuel is not merely technical, it is ecological knowledge. A group must know what burns hot, what smokes, what lasts, what can be gathered quickly, and what is worth carrying back to camp. In a hearth, landscape becomes heat. There is a lesser-known beauty in the way fire changes minerals. Clay can reen, limestone can break down, silica can fracture, magnetic signals can shift. These changes allow scientists to estimate whether a feature reached temperatures consistent with a hearth or with a broader natural fire. They can sometimes distinguish repeated burning from a single event. They can identify whether stones were heated deliberately before tool making. In this sense, the ancient flame leaves behind a physics of behavior. The people are gone, but the minerals remember heat. Yet every interpretation carries humility. A burned layer may look convincing until new analysis shows it formed naturally. A site once celebrated as proof of early fire may become uncertain when its deposits are re-examined. Another site once ignored may become important when microscopic methods reveal hidden ash. Science moves through correction, not just discovery. No single explanation fully accounts for every early trace of fire, because fire use itself was probably uneven, experimental, and variable across landscapes and human groups. The ash reveals a story that is both powerful and incomplete. It shows humans returning to places, gathering around heat, cooking, discarding, working, and sometimes reshaping the ground beneath them. It shows that fire was not merely an idea in the mind, but a physical habit that entered sediment, grain by grain. It also shows how fragile the evidence of ordinary life can be. A night that may have mattered deeply to one ancient group becomes, after hundreds of thousands of years, a pale smear in the earth. And still, that smear is enough to pull the past closer in ash. The ancient hearth is no longer only imagined. It becomes measurable. It becomes a chemistry of survival, a shadow of warmth, a memory of hands placing fuel where the dark could not quite reach. The question of fire mastery sounds simple until it is placed in deep time. When did humans control fire? The ordinary mind wants a date, a place, a beginning. It wants one cave, one hearth, one species, one moment when the ancient world changes forever. But the archaeological record refuses that neatness. Fire does not enter human life like a switch turned on. It appears as scattered clues, debated stains, partial habits, repeated experiments, and long periods where the same behavior may be present in one place and absent in another. The more closely the evidence is studied, the more the question changes. It is not only when humans first used fire, it is what kind of use counts as control. There are several possible thresholds, and they do not have to happen at the same time. One threshold is attraction. Early humans approach burned landscapes after natural fires and take advantage of what the flames leave behind. Another is tolerance. They remain near fire without fleeing, learning its heat, smell, danger, and opportunity. Another is transport. They carry embers from a natural source to a resting place. Another is maintenance. They feed a flame over hours or days. Another is habitual use. They return repeatedly to hearths as part of daily life. Another is production. They can make fire when none is available. These stages may be separated by immense spans of time, and scholars still debate where the strongest evidence falls along that ladder. This is why some of the oldest claims are so controversial. A million-year-old burned fragment may suggest early fire use, but it may not show fire making. A cave deposit with burned plant material may imply humans brought fire into a protected space, but it may still leave open how reliably they controlled it. A hearth, several 100,000 years old, may show repeated burning, but not reveal whether the flame was created by friction, struck from stone, carried from another hearth, or preserved from lightning. The evidence remains incomplete because behavior is often more delicate than the traces it leaves. Fire can reshape a life and still vanish almost completely from the ground. Modern researchers therefore argue not only over dates, but over definitions. If a group finds a burning branch after lightning and carries it to a cave, is that control? If they keep it alive for weeks, but cannot make it again after it dies, is that mastery? If they cook sometimes but not every day, has cooking begun to shape anatomy? If one population uses fire regularly, while another related population does not, can fire be treated as a general feature of the species? These questions matter because the answer changes the story of human evolution. A very early date for habitual fire strengthens the idea that cooking helped shape Homo erectus, bodies and brains. A later date forces more weight onto meat-eating, tool processing, social cooperation, and other sources of energy before cooking becomes central. The debate is sharpened by the body itself. Homo erectus appears with smaller teeth, a more human-like body plan, and a larger brain than earlier homins. To some researchers, this pattern fits strongly with cooking. The body seems as if it has already begun living on softer, richer, more easily digested foods. The jaw does not look built for endless raw chewing. The gut, though invisible in fossils, may have become smaller relative to body needs. The brain is more demanding. From this perspective, habitual cooking may need to be very old, perhaps close to the emergence of Homo erectus. Otherwise, the anatomy seems to be asking for an energy source the archaeology has not yet clearly found. But other scholars urge caution. Stone tools can also soften the energy problem. Cutting meat into small pieces reduces chewing. Pounding plant foods breaks fibers. Marrow extraction provides rich calories. Scavenging, hunting, seasonal flexibility, and social sharing can all improve diet without regular cooking. Climate change may favor bodies that travel efficiently and exploit varied food sources. A smaller tooth does not automatically equal a cooked meal. A larger brain does not prove a hearth. No single explanation fully accounts for the anatomical pattern, and the fossil body cannot be treated as a burned log with a date stamped into it. There is also the problem of preservation. The earliest fire use may have happened in places where it was least likely to survive. Open-air camps on ancient floodplains can be erased by water, wind, and time. Light hearths, made with small branches, may leave little durable charcoal. Tropical environments can destroy organic traces quickly. Groups that carried fire frequently may have left many small temporary burns, rather than clear, deep hearths. If early humans used fire but did not build repeated intense hearths in caves, archaeologists may be looking for a behavior that barely fossilizes. The absence of strong evidence may reflect real absence, poor preservation, or methods not yet sensitive enough to detect what remains. At the same time, caution cuts in the other direction because fire is naturally common in many landscapes. Burned material is easy to overinterpret. A wildfire can burn bones and stones. A tree root can smolder underground and re-sediment. Floods can move charcoal into human occupation layers. A cave entrance can receive wind-blown ash. Later fires can intrude into older deposits. If researchers accept every burned fragment as human control, fire becomes older by imagination rather than proof. The strongest science must hold desire in check. It must allow the past to remain uncertain when the evidence does not fully speak. The debate over mastery also involves different human species. Homo erectus may have used fire in some places and times, but how often remains uncertain. Neanderthals clearly used fire in many later contexts, though even there researchers have debated whether they could always make it easily or sometimes depended on natural sources under certain conditions. Modern humans use fire with deep regularity, but even Homo sapiens inherits a long history rather than inventing the hearth from nothing. The flame passes through a human family tree with many branches, not a single line of heroes. It may have been learned, lost, reinvented, shared or altered many times. A surprising possibility is that fire control may have been culturally fragile for long stretches. A behavior can be powerful without being permanent. Small populations can lose skills if experts die, if environments change, if fuel becomes scarce, if groups disperse, or if a technique is not practiced often enough. Fire making, in particular, may require materials and knowledge that are not equally available everywhere. Keeping fire alive may be easier in some climates than others. A group living in a wet forest faces different challenges from one living in dry savanna. A cold steppe group may depend heavily on fire, while a warm coastal group may use it differently. Human evolution is not one campfire spreading smoothly across the world. It is many fires, some bright, some brief, some extinguished. This unevenness can feel unsatisfying, but it may be closer to reality. Mastery is not a single invention. It is a relationship that becomes reliable. A child born into a group with habitual fire does not need to rediscover its value. The smell of smoke, the danger of coals, the warmth of embers, the taste of cooked food, the work of gathering fuel, these become ordinary facts of life. But ordinariness is itself an achievement. It means a behavior has been woven so tightly into daily routine that the group now depends on it and without constantly noticing its strangeness. The mysterious part of fire mastery may not be the first spark. It may be the long process by which flame becomes normal. That process likely includes failure. Some early humans must have burned food, lost embers, started accidental fires, breathed too much smoke, chosen bad fuel, settled in poorly ventilated shelters, or discovered too late that rain had drowned the coals. Fire is a teacher, but a harsh one. Its lessons are not gentle. Mastery grows through repetition, because mistakes have consequences. A group that becomes skilled with fire carries not only knowledge of how to use it, but knowledge of how not to use it. Keep children away from embers. Do not sleep too close to smoke in a closed place. Do not let sparks reach dry bedding. Do not waste fuel before the coldest hours. Do not assume a coal is dead because it no longer glows. What survives in the record suggests that by later phases of human evolution, fire is no longer rare. Hearths, burned bones, soot, heat-altered stone, and ash appear widely enough to show that humans and their close relatives have made flame part of ordinary life. But the road to that ordinariness remains blurred. The debate continues because the question is too important for easy answers. Fire may have helped feed the brain, soften the diet, extend the day, protect the camp, shape social life, and open cold worlds. Yet each of these claims depends on when, where, and how reliably fire was used. So the debate over mastery is not a weakness in the story, it is the story. It reminds us that humanity was not born from one clean breakthrough. It emerged through uncertain thresholds, partial skills, environmental pressures, cultural habits, and fragile knowledge carried by living groups. Fire became human only when humans became fire's keepers, and that keeping may have taken far longer than any origin myth would dare to admit. Once fire becomes ordinary, it begins to disappear into the background of human life, and that may be the clearest sign of how deeply it has changed us. A rare flame is a spectacle. A dependable hearth becomes expectation. Children are born into smoke and warmth, as if the world has always included a glowing center at night. Food arrives at the mouth, already altered by heat. Camps are planned around fuel. Tools are repaired beside coals. Stories, warnings, gestures, and memories gather where light holds the dark at a distance. At this point, fire is no longer only biology, no longer only calories, no longer only protection. It becomes culture. Culture does not begin as decoration. It begins as repeated knowledge shared across bodies. How to keep embers alive after rain. Which wood burns cleanly. Which smokes heavily. Which makes lasting coals. Where dry branches can still be found after a storm. How close a child can sit before danger begins. Which foods must be roasted longer. Which become bitter if burned. Which roots soften in ash. Which bones crack better after heating. Which hides need warmth to work properly. These are practical facts. But practical facts, passed from one generation to another, become tradition. The hearth is one of the earliest places where survival knowledge may have become inherited, not through genes, but through teaching, imitation, habit, and memory. This shift matters because fire is not self-explanatory. A stone edge reveals its use quickly if it cuts. Fire is more complex. It can cook food or destroy it. It can warm a shelter or fill it with smoke. It can protect a group or expose it. It can preserve meat or reduce valuable material to ash. It demands not just discovery, but disciplined repetition. A population that uses fire well carries a library of invisible rules. The evidence remains incomplete because rules rarely fossilize. Archaeologists may find hearths, burned bones, pigments, heat-treated stone, and soot-darkened ceilings. But the meanings attached to those fires are much harder to recover. Still, by later prehistory, fire clearly becomes more than a camp utility. It enters the symbolic world. Caves with art require light, and the light is often flame. A hand moving across a cave wall tens of thousands of years ago does not work under the sun. It works by torch, lamp, or hearth glow in a darkness made navigable by controlled fire. Flickering light changes the painted surface. Animals seem to move as shadows tremble across stone. The uneven wall becomes part of the image. Pigments are mixed. Lamps burn animal fat. Torches smoke against ceilings, and human presence reaches into spaces no daylight can touch. Fire does not create symbolic thought by itself, but it makes certain symbolic worlds possible. Ochre and heat return here in a new role. Pigment can be practical, but it can also mark bodies, objects, places, and identities. Heating minerals can change color. Grinding and mixing pigments requires intention. A red stain on shell, bone, skin, stone, or cave wall can carry meanings that modern science may never fully translate. Scholars still debate the exact purpose of many pigment finds: decoration, hide processing, adhesive recipes, social marking, ritual practice, or combinations of these. No single explanation fully accounts for every case, yet fire's power to transform color, food, and matter belongs naturally to a mind increasingly alert to transformation itself. Cooking also becomes cultural long before written recipes. A cooked meal is never just chemistry. Once it is repeated socially, it has timing, preference, skill, expectation, and memory. Different groups in different landscapes would have learned different relationships with heat. Some foods roast well in open flame. Others require embers. Some are best wrapped, buried, smoked, dried, cracked, pounded, or warmed slowly, without pottery. Boiling is difficult, but not impossible in some later contexts, using heated stones and bare containers of hide, bark, wood, or other materials, depending on technology and preservation. The deeper point is that cooking becomes a way a group knows its own world. The taste of survival becomes local. Around this local knowledge, identity can form. A group may recognize itself partly through the foods it prepares, the way it shares meat, the placement of hearths, the treatment of bones, the handling of fuel, the timing of evening gatherings, and the stories attached to certain places of fire. The archaeological record cannot easily show identity in the emotional sense, especially in the earliest periods. But later human societies everywhere bind food, fire, belonging, and memory together so tightly that it would be strange if the roots were shallow. The hearth is not only where bodies are fed, it is where the group becomes familiar to itself. There is another reason fire becomes culturally powerful. It is visibly transformative. It takes wood and makes light. It takes flesh and changes smell. It takes clay and in later times makes ceramic. It takes ore and much later releases metal. Even before those later revolutions, the basic experience is extraordinary. Fire is mattering state before the eyes. It is destruction that produces use. It is danger that can be invited near if treated correctly. For human minds that increasingly search for patterns, meanings, causes, and hidden forces, fire offers endless material. It is natural that flame eventually becomes sacred in many societies, guarded in temples, used in rites, linked to ancestors, purity, renewal, punishment, and creation. Those later meanings cannot be projected directly onto the first hearths, but they show how deeply fire lends itself to symbolic life. The long evening may be where this symbolic life begins to thicken. A group gathered after dark does not only exchange practical information. Over time, it can remember the dead, warn children through narrative, imitate animals, explain dangerous places, repeat routes, mark seasons, and turn fear into shared form. The first stories are gone. No ash lens can preserve a myth. No burned bone can tell us whether a child heard the tale of a leopard, a river, a storm, or an ancestor. But the setting is right: light, faces, food, safety, darkness beyond the circle, and hours that would not exist in the same way without flame. Fire gives memory a stage. It also changes the dead in much later periods. Cremation, ritual burning, offerings, and ceremonial hearths become part of human societies in many regions, though not everywhere and not always with the same meaning. These practices belong to cultural worlds far beyond the first controlled fires. Yet they reveal a recurring human intuition. Burning is not ordinary disappearance. It is transformation. A body, an offering, a tool, a structure, or a meal placed in fire crosses a visible boundary. The material world becomes smoke, ash, scent, heat, and memory. That power would have been hard for any observant human group to ignore, but caution is necessary. Not every prehistoric fire is ritual. Most fires were probably practical cooking, warmth, light, protection, craft, waste disposal. Popular imagination sometimes turns every ancient hearth into a sacred altar which is unsupported. The ordinary hearth is important enough without exaggeration. In fact, its ordinariness may be the source of its sacred potential. What is repeated daily becomes emotionally charged. What keeps children alive becomes meaningful. What gathers the group becomes identity. What transforms food becomes metaphor. Culture grows from use before it becomes symbol. By the time fire is fully cultural, it has crossed a threshold deeper than technology. It is no longer merely something humans use. It is something through which humans understand change. The hearth teaches that the world can be altered, that raw things can become nourishing, that darkness can be held back, that matter can become memory. It anchors daily life while opening the imagination beyond the immediate day. And as the flames rise and fall across countless generations, the human story becomes not only a story of bodies adapting to fire, but of minds learning to see in fire a mirror of themselves. Hungry, dangerous, social, fragile, and capable of turning one thing into another. The legacy of ancient fire is easiest to miss because it is everywhere. It is in the kitchen flame, the oven coil, the warm bowl lifted to the mouth, the streetlight holding back night, the furnace humming behind a wall, the campfire that still draws silent attention from people who may spend the rest of their lives surrounded by machines. Modern humans no longer live by a single hearth on open ground, and yet the old arrangement survives in altered form. Heat still changes food before it enters the body. Light still extends the day. Shared meals still organize families, friendships, rituals, and memory. The ancient flame has spread so widely through human life that it no longer looks like a tool. It looks like the background of being human. The body carries this history quietly. Human teeth, jaws, digestive systems, and energy needs make most sense in a world where food is often processed before eating. Cooking is not the only processing humans use. Cutting, grinding, fermenting, drying, pounding, soaking, and later agriculture all change food before digestion. But heat remains one of the most powerful transformations. A cooked meal is partly digested outside the body by fire, steam, hot stone, ember, oil, or metal. The mouth meets food already softened. The gut receives matter already altered. The brain, costly and restless, lives on energy made easier to obtain by behaviors older than civilization. Scholars still debate exactly when this dependence began and how completely it shaped early science anatomy. But the modern human relationship with cooked food is no minor habit. It is a biological inheritance carried through culture. Even the modern face may be part of that inheritance. Smaller jaws, reduced chewing demands, softer diets, and processed foods have continued to influence human development in recent times, sometimes in ways that create new problems. Crowded teeth, impacted wisdom teeth, and changes in jaw growth are often discussed in relation to softer modern diets and reduced chewing stress. Though the details are complex and not explained by cooking alone, the point is not that every dental problem began at the first hearth. It is that food preparation has been shaping the human body for so long that culture and anatomy can no longer be neatly separated. The fire outside the body became part of the body's evolutionary environment. The same is true of night. Artificial light is not fire in the old sense, but it descends from the same rebellion against darkness. Torches, oil lamps, candles, hearths, lanterns, gaslight, electricity, and screens all continue the ancient act of extending human activity beyond sunset. The first firelit evenings may have allowed more social time, teaching, memory, and rest. Modern light has expanded those hours almost without limit, sometimes beautifully, and sometimes harshly. Cities glow from orbit. Work continues through the night. Sleep is delayed, interrupted, shortened, and reorganized. The gift that once helped humans hold a small circle against predators has become powerful, enough to disturb the rhythms of the body itself. Fire's legacy is not only comfort. Like fire, it is double-edged. Cities are giant hearths, though their flames are hidden. They burn fuel, move heat, cook food for millions, forge materials, power transport, and keep darkness away. Long after humans stopped sitting every night around a single visible flame, civilization became a vast system of controlled combustion and stored energy. Clay hardened in kilns, or became metal. Forests became charcoal, coal, oil, and gas, turned ancient sunlight into industry. Engines carried fire inside metal chambers. Electricity moved its consequences through wires. No single explanation fully accounts for the rise of civilization and agriculture. Language, trade, writing, law, and geography all matter, but the line from hearth to furnace to engine is real. Humans did not merely use fire to survive, they used it to rebuild the planet. That rebuilding has consequences. The same mastery that warmed camps and cooked roots eventually helped create smoke over industrial cities, carbon in the atmosphere, forests cleared for fuel, and climates altered by combustion on a scale no prehistoric firekeeper could have imagined. This does not make the first half guilty of the modern world. It makes the story more sobering. A force that begins as survival can become power, and power can outgrow the wisdom that first contained it. Ancient fire required attention, restraint, fuel knowledge, and respect for danger. Modern fire, hidden in systems too large to see, still asks for the same things. Yet fire's human legacy is not only industrial, it remains intimate. A person cooking for another person is participating in one of the oldest forms of care. A shared meal still carries trust, obligation, affection, status, memory, and belonging. Food warmed in a kitchen can comfort the sick, welcome the stranger, honor the dead, celebrate a birth, mark a season, or restore an ordinary evening. The hearth has changed shape, but the emotional pattern survives. Heat transforms food, and shared food transforms relationships. There is something remarkable in that continuity. The first groups who guarded embers against night could not know that one day humans would study ash under microscopes, debate energy budgets, sequence ancient DNA, measure brain metabolism, or trace soot inside caves to reconstruct vanished evenings. They could not know that their small fires would become a symbol of home, danger, knowledge, industry, destruction, purification, memory, and invention. They knew the immediate truth of warmth, hunger, darkness, and light. But evolution often works through immediate truths. A habit that solves tonight's problem can guess, over countless generations, alter the future of a species. What survives in us is not a single spark, but a relationship. Humans are animals that learn to live with transformation. We learned that raw things can become edible, hard things can become workable, dark spaces can become social, cold places can become habitable. and dangerous forces can become companions if tended carefully. Fire did not make humans alone. Walking, hands, tools, meat, plants, climate, cooperation, childbirth, childhood, memory, and chance all shaped the path. But fire gave that path a glow that can still be seen. It fed the body, lengthened the evening, gathered the group, trained the hand, challenged the mind, and left behind ash where the ancient night once pressed close. The fire that made us human is not gone. It burns in quieter forms, inside meals, machines, stories, and bodies that still depend on transformed energy. Every cooked meal is a small return to deep time. Every face, lit by flame, belongs for a moment to an older circle, and every ember, however ordinary, carries the memory of the first humans who discovered that the dark could be met, not by becoming stronger than the night, but by learning how to keep one fragile light alive. The story ends where it began, in darkness. But the darkness no longer feels empty. It has held too many lives, too many vanished camps, too many hands reaching toward warmth. The ancient landscapes are gone in their old forms. The grasslands have shifted. The caves have filled with sediment. The bones have broken into fragments. The smokers disappeared into air that moved on long before any name could be given to it. Yet somewhere in the earth, a thin lens of ash remains, pale and quiet, waiting for a careful eye. The people around those fires did not think of themselves as ancestors to a world of ovens, satellites, laboratories, and glowing cities. They lived inside immediate weather. They knew hunger before theory, warmth before chemistry, night before myth. Their fires were small. They could fail. Rain could drown them. Wind could scatter them. A careless hand could turn comfort into injury. But while they burned, they made a center. Around that center, bodies rested, food softened, children watched, elders remembered, and the dark stepped back. Human history often seems to belong to monuments, empires, battles, and written names, but the deeper history is quieter. It is the repeated act of keeping life possible, a branch placed on coals, a child pulled away from sparks, meat turned before it burns, embers buried beneath ash for mourning. These acts left almost no voice, but they shaped the animal that would one day ask where it came from. In the end, fire is not only a story of mastery, it is a story of dependence. Humans became powerful through something they could never fully own. Flame had to be tended. It had to be respected. It gave warmth only while being fed. It answered care with light and neglect with darkness. Perhaps that is why it still holds the eye so easily. In its movement, there is danger, memory, and a kind of ancient honesty. Long after the first hearths vanished, we remain creatures of borrowed heat. We carry the old fire forward in our food, our tools, our shelters, our restless nights, and our need to gather around brightness when the world grows cold. The flame is small again now, somewhere at the edge of a prehistoric camp, trembling against stone and grass. Beyond it, the night waits. Within it, a human face appears, then another, lit for a moment before time closes over them like smoke. Thank you for listening. If you would like to join me for more stories, I would be grateful if you would subscribe. Sleep well and be kind to yourself.